Okay, so it is time for day 5 of Advent of Code. Sorry about my voice today. I'm not feeling great. Okay, so let's read through it. Day 5, supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, which is our puzzle input, for example. And then we can look at an example here where we have, so we have 3 stacks. You know, the first stack has Z, N, and the second stack has M, C, D, and the third stack has P. Which is the same thing that this explains. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, move 1 from 2 to 1, we would take move 1 crate, which is the D crate, from stack 2 to stack 1. So D would end up over there, which is what we can see down here. Okay, in the second step, 3 crates are moved from stack 1 to stack 3. Crates are moved 1 at a time, so the first crate to be moved, D, ends up below the second and third crates. So we can see that here. This down here is what we get when we take D first and move over here on top of this one, and so on and so on. Okay, the elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. So you should combine these together and give the elves the message CMZ. After the rearrangement procedure completes, what crates end up at the top of each stack? Okay, so this one was pretty tricky actually, mostly because of this initial state right here. Trying to find a way to parse that out that didn't make me want to cry was a challenge. Okay. Okay, so this is what I ended up with, but let's take a look first. So first we parsed the file. I had a bit of a false start because I have this get lines that I copy every day, because every day there's some input and you need to parse it, and it's handy, right? But this line here used to just read L equals L dot strip, which meant that the strip method on a string in Python removes any white space at the start or end of a string, which is usually handy when you don't want to deal with the white space when you're parsing things and you're getting all this stuff done. But in this particular case, let's look at the sample here. So there's some trailing white space, ignore that. But if you are removing all the leading and trailing white space, it's going to look like this. Oh, wait, why isn't that up? Okay, there we go. Yeah, it's going to look like this, right? And that's not what we want. That's bad. Right, so we want to do this. Okay. So a bit of a false start there. Yeah, this is terrible, honestly. So once again, if we look at this line here, right? I used the last line before the first empty line. So whenever we see the first empty line, let's go back here. my parse file, right? So I get all the lines, not stripping the white space. And then I have my before lines and my move lines. The before lines are, everything before that first empty line, after which we have all the moves, right? So we're reading the state, the current state. If we see an empty one and we're reading state, then we change to reading moves. So we have a small state machine here. If we are reading state, we add the line to a variable called before lines. And if we're reading moves, then we add the move lines. And if we're doing anything else, then something has gone terribly wrong, right? So, okay. So before lines contains these 4 lines here. Okay. And then I look at the final. I want to parse out all the numbers on that line. And then I want to take the final number because that tells me how many stacks I need. So that is basically what I do here. And this is really hard to read, but I put an example down here where you can see where I'm using that same method here. Let me just... Right. It's a lot of parentheses. I hope you can follow along. Okay, so before lines -1. So that's the final line of before lines. So that would, I just created a sample line here with a varying number of white space. The regular expression library has a split method too, which is super handy when you don't know how much white space is going to be and so on. So I use that, and that gives me all of these. It gives me all the numbers and a couple of empty values. So that is my output from this expression right here. Then I filter so that I only keep the strings that have a length of greater than 0 after being stripped. So if they have any contents at all, I keep them. And then the assumption is that any of those are going to be integers, so I map them to integers, because I'm parsing them from the file, so they're a string, and I turn them into integers. So that's, and in a list, and then I take the final number in that numbers list, and that's the number of the final stack. So that is my number of stacks. Yeah, real awkward. I mean, this is one of those situations where sometimes when you see people doing this really fast, people who are speed solving these things, instead of parsing the file as it is, they will spend some time redoing it because that's faster. So in this situation, I could probably have done something like changed it to something like that, right? So it's horizontal instead of vertical. That would have made parsing it out so much simpler. But sometimes when that works for the sample, it doesn't work for the real input, because the real input is enormous. I don't think that was the case here. Let's see. No, only 9 stacks, which is manageable, but would still been a hassle to do this. Okay, so I create a stacks variable, which is a 2-dimensional array. Each first level element in there is a stack, and then obviously that array, second level array, just has all the elements that are in that given stack. Then I look at each of the lines. I skip the final line, which would be -1. So -2, I go from -2 So the second to last line in the before lines, and this -1 here means that we go backwards, we iterate backwards. Okay. So this for loop goes through each of the lines here. So this line first, and then this line, and then this line. And for each line, we go through however many stacks there are, and we calculate the index of the crate in that on that line. So 1 plus x times 4. So x is the index. So you can see. I'll just type out the indices. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So that's the first one. So that's at 4. The first index is going to be 1, and then they're spaced 4 apart. So it becomes pretty simple, just saying 1 plus x times 4. And then in case this check right here is there to prevent or handle the case where you can see here, VS Code highlights the trailing white space. If that hadn't been there, this would have failed, right? So I just put that in just for safety. All right. And then, really, this line right here should be unnecessary. It's just, I like to be a little defensive. But yeah, this should ensure that what we're looking at is actually an uppercase character, which is what the input looks like. And then we add it to the stack, to the correct stack. And that's it. All right, so once we've parsed the stacks, we know we've basically created in this case, we have a 3-dimensional array. No, nonsense. We have a 2-dimensional array where the first level has 3 elements, and the second level then has Zn and MCD and P. Okay. So once we have that, part A becomes about moving the stuff here. Okay. So we create this move function here, which takes an input of stacks, and then it's the from stack and the to stacks, because we're only ever moving one at a time. And then because they are 0 indexed, because we 0 index stuff because that's how things are easy, but the file is not 0 indexing, it's 1 indexing, so we always have to subtract 1. So we do that. So basically we pop an element from the from stack and shove it onto the to stack, and then we return the new stacks. So the move function takes the stack and applies a move and gives you the new sets of stacks. Once again, we use the regular expression library to parse out the count and the from and the to stack. And that's what we do here. We find the matches, and then we turn them into integers. And then for each count, we perform the move, and then we return the top elements of each stack. And boom, that's it. That gives us the answer. And in my case, that was FWSHSPJWM. Okay. Part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a Crate Mover 9000, it's a Crate Mover 9001. The Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration. Okay, so you can see that the first step here is the same. You move D over 1, which is what you get here. But then you move 3 at a time from the first stack to the third stack. And then you can see down here that you move 3 at a time and their order is maintained. So unlike the first part, you can move multiple at a time and they keep their order. So that's it. And obviously we can use most of the same code again. The only thing that changes is this move thing. And yep, the way that we do that is we extend the move function to have the count. We could have done that before, but we didn't. So it has the count. And in the 2 stack, it adds, this right here returns like the top count crates from the from stack and moves it onto the 2 stack. And then we set the from stack to be the from stack minus those count crates on top. And then we just do the same thing again. We parse it out, we find the count and the from and the 2, we perform the moves, and we return all these. And that's it, pretty much. Let's see. Yep, that gives me a slightly different answer. And yeah, that's it for day 5. That parsing thing was really frustrating, especially because I kind of tried to do it on a timer. But yeah, it took a while, but we got there in the end. So yeah, that's day 5 of Admin and Code. If you have any questions, leave them below. Otherwise, just like and I guess subscribe. All right.